Great. Hello, everyone. Thanks for coming. Wanted to talk about um, some of the work that we're doing in C++, um, and talk about some of the motivation for some of this work and what this means for really the future of Presto. So I'll start with a little bit of background. So like the Presto project since late 2020 or mid to late 2020 has been um, working on essentially rewriting its evaluation engine in C++. So why have we been working on that? The reason is that Presto has been a purely JVM-based project basically since its founding. This enabled Presto to move very fast and gave it really kind of like the initial traction that helped it grow in popularity. But it also presented challenges as Presto matured and as Presto was used in large deployments or basically non-trivial deployments. So the first thing that is probably familiar with anyone who has operated a very large scale JVM deployment of any kind of infrastructure is that what we found is that like basically garbage collection um, caused a lot of performance and reliability overhead for Presto. So what do I mean by garbage collection? Java is is a language that doesn't really explicitly manage memory. What it does is it relies on a garbage collector to repurpose and kind of like defragment, areas of memory. And so this is a tremendous convenience when developing Java code, but it also means that a lot of the performance and reliability of your code is outside of your hands. Essentially, it's kind of like dictated by a garbage collector. So when you think about what Presto is, and like I'll get there's some images to help visualize this, but essentially, like let's say you have like a 500 node cluster, all 500 nodes really need to be acting in unison, and they have to be equally performant and equally reliable. And in a system like Presto, if one of those ends up kind of like flaking or dying or has like a lot of garbage collection, that impacts all 500 nodes. Basically, the lowest common denominator node in your cluster ends up kind of like defining the performance and reliability. So this ends up, like for if, as you go large, this ends up being a reliability problem. Not everyone, has large clusters though. So what are some of the other benefits? Or what are some of the other motivations? It does tend to kind of like revolve around memory and CPU. So going back into, garbage collection, even if you're not using kind of like a large scale deployment, another reason to avoid using garbage collection is you're very, very constrained on how you can use memory. Essentially in the JVM, everything um, there's only one memory management mode. Whereas in Velox, and I can link to references around this, you have a lot more flexibility in how to manage memory and like as we've been moving into C++, we've been taking advantage of that. So you also get performance benefits when you manage your own memory. Another reason is that if you use a native language such as C++, C, or Rust, you can better use instructions that are available on the hardware that you're deploying in. So most modern CPUs have what's called vectorized instructions, meaning they do many things at one time. So like they'll basically perform the same operation over many different bytes of data instead of one by one, which is kind of like before vectorized instructions. That was how you would go about that. It turns out that in data, vectorized instructions can provide a tremendous boost. And so this shows up in all sorts of places, from scan joins, really to most of the core operators that exist in your query engine can benefit from doing many things at once versus things one by one. So, like some of the motivations include reliability, performance, and then a third motivation really is kind of like a little bit more abstract and farther looking, but like the trend over the past maybe decade and a half is that like what we found is that the database really just keeps on getting split up into smaller pieces. So like it started with storage, and like we see that the catalog has been split up, and like then you get all sorts of different interfaces into your data lake. And so um, I think it's fair to say that disaggregation drives a lot of the cost savings and the innovation that have happened in modern databases, and it seems to be going more and more in that direction. Like old school data warehouses where everything kind of like is in one appliance are all moving towards Iceberg, into open data formats, and even cloud data warehouses are kind of like opening up and further disaggregating. So the promise that working toward a C++ based execution engine gives is that really you can also disaggregate the execution side of the query engine. So why would you want to do that? The reason why you would want to do that is you can get economies of scale and get better, more people really working on a focused area of the database, and focus your energies on kind of like a better user experience, or better integration to other parts of the warehouse. So this is something that I think will be the future. And I'm really excited for Presto to be kind of like at the cutting edge of that. So, so I started off, I hope that all makes sense, like why we're moving to C++, why we're spending so much of our effort onto this initiative. So I hope everyone can see at this point, like why this is beneficial, why this is going to kind of like move Presto forward. And, this will be kind of like a step function improvement in Presto, to the extent where we're saying like we want to call this like a major version of upgrade of Presto. It's such a big change. So in this context, we're talking about kind of like how do we solve some of the challenges as we move on to C++, and what does this mean for Presto? So that's kind of like the topic of today's conversation. By the way, if there's any questions, feel free to put them in chat. I'll be happy to take a look at that. So, we've been working on C++ for several years now. Where are we at, and why don't we just kind of like make C++ the default right now? Well, you can certainly try it. It's in our documentation. We've added documentation on how you can, use it, and if you use Iceberg or Hive, you can use it right now. Some of the stuff just still doesn't work quite. It doesn't really work right now in C++. So I think one big thing that doesn't work in C++ right now is that there's no real connectors. So if you think about and plugins in general. So if you think about Presto, and one of the kind of like awesome features of Presto, it's that you can really plug and mix and match code and customize Presto to do exactly what you need it to do. So that's some examples include the connector architecture, authenticators, like resource groups and resource group managers, all sorts of different ways that you can customize Presto. So the things that you can customize on the worker are replicated, but you don't have that dynamic ability to add a new connector right now. So that's like I think a big gap. And this includes both connectors, types, and functions. So like Presto C++ really only supports a certain set of built-in types and functions. So you can't just kind of like plug in your own function yet. And then as we work through really just kind of like re-implementing the eval in a vectorized way, we find that certain things are just very, very different and are either inadvisable to make completely the same as the way it was in Java, or just very hard. So for example, like array sort, the contract for array sort is that you can take in features of lambda in the function, and the lambda can inform how to sort the array. That lambda is very hard to vectorize. And so for C++, we've written an alternative approach to that that has less pitfalls and is easier to vectorize. What I mean by vectorize is execute many things in parallel. So just give you that really big performance boost. There's all sorts of other things too, like the regular expression dialects all differ in lots of different ways. That like you can imagine it's kind of its own language. To bring completely identical semantics into that syntax is a challenge. And then there's some things that just don't exist, that exist in C++ but don't exist in Java. So like, for example, merge sort is something that exists in C++ because Spark needed that. And so you have this kind of like mismatch between the two evals. So that's what I'm talking about with split brain, where there are certain areas where there's a little bit of kind of like a difference in understanding between what the Java-based coordinator thinks should happen and what the worker thinks should happen. And so that causes a few issues. So there are a few gaps, but really we want to make C++ the default. So like, I think within the Presto community, especially among the Presto committers, we know that moving to C++ is just gonna put us really to the next level in terms of performance. It's gonna be it's gonna be it won't be comparable. So C++ really I think like we're preferring the C++ approach because just the performance will be so much better. Why is that important? Well, if you think about what Presto does and what we would like for it to do, we don't want it to just do ad hoc querying. We also want it to replace any data warehouses that you have. And we also want it to even replace, like your OLAP engines. And in order for it to fill those use cases, it has to be written in native because the data warehouses and OLAP engines are very, very performance tuned. So we want really for Presto to be the default thing that you use in all these different settings, and you can't do that without great performance. So to us, it's not just good to have correct performance. It's also slightly existential. Like you need this good performance in order for Presto to do what it needs to do. And then also we expect that by moving into a common eval, we can get these network benefits where really this common eval is going to move so much quicker than anything else out there in the open source ecosystem that it will be kind of like a no-brainer. But the flip side of that is that by working on C++, some of the Java stuff we're not really paying such close attention to. So not only do we want to move to C++, we want to move to C++ as soon as we can. And we'd also like to delete a lot of our, just from putting on my software engineering hat, we'd also like to delete a lot of the code in Java as we move to C++. So now we'll get into how do things work right now and how we're going to change it. Really all we do is, let's see if I can get an example here. So really all we do is we just kind of swap out a worker and replace it with a C++ equivalent. So that's all we do. So like instead of like having a Java-based worker, you have a C++-based worker, and everything kind of just works. And this really kind of like gets you a lot of the functionality in Presto. And some of these are kind of like technical, so I won't go in too much depth, but essentially, like the instructions that are sent into the workers or the C++ workers really just kind of understand the exact same message, whether or not it's a Java or C++ based worker. So we just swapped them out and we've re-implemented these worker boxes purely in C++. Um, Now, this is kind of like a topology view. So Presto, you have a Presto coordinator that manages a lot of workers and makes sure that they execute queries, stream results, and that they communicate amongst each other. If they've failed, then propagate that failure up and really just do the resource management. So this is, how a Presto cluster works at a extremely simplistic view. So this is like a topology view. So like if you have four process cluster, this is probably how it would look like. Um, there's also the point of view of like, well, how does it work from a logical perspective? So coordinators have lots of different, functions, and all of these are pluggable. So coordinators in the coordinator, you can customize the functions and types you have. Just you can give yourself, add user-defined functions and types, add new connectors, event listeners in case you want to monitor your Presto clusters, authorization, um, and authentication, um, resource management, all sorts of things. And some of these also exist in the worker. So like some of these, like functions, the coordinator understands, well, what functions do I have so that it can parse your query? And then the worker has, well, here's the function that I have so I can execute them and give query results. So I've illustrated that where, you have these blue boxes where there's kind of like a overlapping or shared understanding of what is a configurable, what's a configurable, um, what is configurable within the process. And you can categorize all these ways that you can configure Presto into kind of like two different buckets. The first is the shared usage, and second is diversion usage. So the shared usage means that, if I'm customizing Presto and I'm adding a new function, and I write a plugin and I give it to Presto to add the function, I'm going to give it both to the coordinator and the worker because both of them need to know that the function exists. The coordinator needs to know that it exists, what types it has so that it can parse a query, and then the worker needs to know it so that it can execute it and give query results. So then, as we've been working on the C++ feature, the way that we've done it really is that there, all these things exist within Velox, but Velox doesn't have the same. Velox, by the way, is our shared C++ evaluation engine library. This is where we're putting the majority of the work in the C++ worker. So the way that we've been approaching it is that these exist inside of Velox, and Velox just happens to contain the same functions and types and any relevant connectors. So this works pretty well for if you're using Hive and now Iceberg, but there's also like some problems that we need to fix. So the first is that like show statements are inaccurate. So for example, if you do show functions, it'll actually just return the Java functions. It won't return the actual functions that are in the C++ side. Certain things fail when you try to give it to the worker, because that failure happens when the query starts to execute, not when it's parsed. Um, there there's some certain incompatibility between kind of like what's um, Velox is able to do and what Presto thinks Velox ought to be able to do. So you have this problem where um, there's just like a kind of like a lack of communication between what the coordinator thinks it should be able to do versus what Velox actually is able to do. And so at this point, some of these are um, uh, like relatively small. So for example, like I think timestamps, like there's certain types, certain DDL statements. For the majority of things, there's feature parity. It's just that there's like this long tail of stuff that there isn't feature parity yet, and it's not clear when there will be. So what we want to do is we want to at the very least give people an SPI. So basically the ability to provide a plugin. And the reason why is that plugins have really always been critical to Presto's adoption. So, Presto never really took never was really tightly coupled to Hadoop when Hadoop was big. It abstracted all that through the plugin interface. And in general, as I think, these systems get more and more disaggregated and decoupled, um, it's important to not have this tight coupling to the underlying components that you need. You should not only provide support for kind of like common infrastructure, but you should also have support for infrastructure that Presto doesn't know about, because people operate in businesses that might have custom stuff, and so you need to integrate with that custom stuff. Um, so um, uh, because of this, you also need to, like, until we get this like complete feature parity, we also need to know, well, how can I use a Presto C++ cluster? Like, how do I know if I have a Java cluster and C++ cluster, how do I know which one I can use? And that's a very difficult problem for interactive or ad hoc queries, because we don't know anything about the query before it comes into Presto. So, like, we need really kind of like an oracle that tells us, is the thing that we're sending compatible with C++? So, the thing that we really need is the ability to communicate back to the coordinator and inform it, like, what does it support? And so, like, like the custom functions, custom types, custom connectors, um, the things that people use to customize Presto, um, should be able to be communicated back to the coordinator so that there's consistency. So that, like, if you do show functions, you list all the correct functions. You can validate functions, and you can add your own connectors. So a big thing that we would like to do is add connector support, but really we want to tackle the whole range of customizability that Presto has and give that into C++, so that people can use C++ clusters um, in the same way that you can use a Presto Java cluster. So we want to kind of like give that customizability aspect that makes Presto awesome and put it into C++. And so instead of kind of like picturing functions, types, connectors as a box, and you must fit within this box, what we want to do is we want to say, like, you can bring your own functions, your own types, and your own connectors, and Presto will just work. So that's what we're working on. So and that's where the sidecar comes in. So the question is, like, how do you know, how do you communicate some of that stuff that's in C++ into the Presto Java coordinator, so that you have all these features that kind of like give you more feature parity between C++ Java clusters and Java clusters, and that's where the sidecar comes in. So the sidecar is a native process that has understanding of the underlying capabilities of the execution engine, and is able to communicate with the coordinator and tell it, what it supports, what it can do. So a few examples of what this would enable a Presto cluster. So if we want to add custom C++ functions to a C++ cluster, this would allow those functions to be communicated back to the coordinator, so that when the coordinator parses a query, it is able to determine that you've added a new C++ function. Another example would be if you've added a custom type to Presto. This would communicate back to the coordinator that you've added that custom type. Some other examples would be custom plugins, connectors. So if you've added a custom connector, once again, this goes into the coordinator. And then also, if you attempt to use a feature that isn't supported, so for example, there are a few examples. So like geospatial types are not supported in C++ right now. If you attempt to do that, then we have a validation that is, we validate that at planning time, just like queries are right now. So like if you attempt to use geospatial, like we give you validation that isn't supported. So the whole purpose and idea is really to kind of like give you this validation and upfront information, so that the planner and the parser inside of the Java coordinator can use that to, kind of like give correct error messages. We can use this for routing between C++ and Java clusters. And you get correct information when you try to inspect like what functions do I have, what types do I have, things of that nature. So that's the purpose of the sidecar. I think like this information, I'll just kind of like skip over this a little bit just because this is a little bit low level. But I think the long story short is that we'll be building this. This will be kind of like a built-in feature in Presto, and as we kind of like increase our C++ adoption, this will be used to help users of C++ clusters get a better native experience within Presto. We also will be supporting, in addition to adding connector support, we'll also be adding remote connectors in the form of Aeroflight services. So I'll take a second to explain what I mean by that. So one of the challenges as we move to C++ is well, how do you take all the stuff, like let's say you're an existing Presto user. How do we take all the stuff that I've built in Java and make it not obsolete or not something that I need to rewrite from scratch? So, like Presto has dozens of connectors. Many of them are very widely used. Lots of different Java functions. How do we make it so that we don't have to rewrite everything from scratch? And the idea is to put it behind a service. By putting this behind a service, we can separate, the language from the functionality. So whereas, kind of like re-implementing things in C++ would be very onerous. Not everyone knows C++. You might be in a data engineering organization that doesn't use any C++. This would allow you to continue to use Java to define a connector. All you would need to do is develop a service that implements the connector API. Under the hood, this will look like Aeroflight. So if you have other services that use Aeroflight, you could also just use that. But the idea is to translate Presto's internal protocol for how it defines custom data sources and make it a little bit more generic using the Aeroflight API and try to move towards a more vendor neutral format. Or not vendor, but a more neutral format that is, kind of like not Presto specific, just because there's also objective uses for using Aeroflight. Could be with other services, Aeroflight SQL, certain databases are exposed, kind of like expose Aeroflight APIs. There's lots of benefits for integrating with Aero. And so we would, are intending to basically just kind of like, settle both use cases by moving on to Aeroflight. So this would be, kind of how you end up moving an existing connector into a new C++ cluster. There will be a shim that's provided that where you really won't have to write code. You'll just have to start a process that takes in the plugin that has already been written for a connector, and it will just sort of like translate that into Aeroflight. So it won't require tremendous, or it won't require much, or really any coding. It will just provide kind of like a translation so that an existing inter-process connector can be exposed as an intra-process service, which Presto can then query. This is, kind of like the path forward for how we intend, C++ clusters to eventually be the default. There's a lot of there's still many different open questions for, how do we handle things like, slightly different semantics of functions or slightly, slight differences in behavior. And, like these tend to follow a Pareto distribution is what I would say. So, 80% is straightforward, and then you have like this long tail of things that are either questionable to bring into unison between Java and C++, or just very, very difficult. And so this is why, like for C++ clusters, we'll be considering this a major version upgrade. So, like when you upgrade Presto into C++, after a certain point, once we've, kind of like fixed some of the feature gap that exists between Java and Presto clusters, certain things will be different. And we will document those differences. We will provide Helm charts and migration guides to move between Presto 0.x to Presto 2.x. But essentially there will be small differences that will be documented, and we will provide code and helpers to get people to migrate between one and the other. So that would, essentially be the strategy. Rewriting, kind of like providing identical behavior between these two clusters, like is essentially, I would not say it's impossible, but I would say that it's it would take too long. And so we'll be offering a way for, basically a trade-off where if certain feature differences are acceptable, you can hop on board to the C++ train. And that's the overall idea. So I think like that's essentially what the Presto Sidecar is all about. Like we will be working, like we've been working, I think, for the past few months, but we'll continue to work on various different functionality that we would like to provide through the Presto Sidecar, including well, basically all the things that I mentioned. So remote connector support, the ability to add, functions and types, the ability to validate that plans will be compatible with C++. So definitely expect, details on that through the release notes and updates to our documentation. And we'll also, I expect that we'll also be providing, more meetups and talking about this at the Presto TSC meeting as we make kind of like these, achieve these various milestones and start to add a lot of the support. So that I think is all I had, and I'm happy to answer any questions if anyone has any.
Cool. Thank you, Tim. So if you do have a question, feel free to go off mute if you're on Zoom, or type it into your LinkedIn live chat or Zoom chat. While we wait to see if there are any questions, I'll just share kind of how to get involved with the community. So if you're not there already, please join us in our community Slack channel. We do also have a channel in our Slack workspace dedicated to Presto C++ and all the work going on there. So it's a great way to connect with all the engineers working on this and get more involved. Of course, contributing to the project is great. If you're in here, you're most likely part of our meetup group. So thank you for being a part of that. And then we do also have working groups. Native worker is one of those topics. And then finally, I always get this question. We did record this, and I will post it in our Presto Foundation YouTube page. All right. Well, thank you, Tim. I think that was a ton of content to digest. But we'll get the slides out and the recording out as well. If you're in Slack, I think I'll just say it on behalf of you, Tim. Feel free to ping Tim if you have any specific questions there as well. Good place to connect with him. All right, with that, folks, thanks a ton for joining. Hopefully we'll see you next month at our next meetup. And thanks again. Thanks, Tim.